Good morning, everyone, and welcome to our virtual class in quantitative methods. Today's topic would be about basic statistical concept, and we are on our first week of discussion for the whole trimester 2113T. Again, my name is Mike Perez, your OLC for this subject. The objectives that we have here for today are the following. First is to define statistics. Second is to discuss, differentiate, and solve problems regarding the measures of central tendency, differentiate the different measures of dispersion, and as well determine the purpose of statistics in the different fields like business, economics, mathematics, and banking. So let's get started. First is the definition of statistics. You would see here numerous definition that was based from different books and online resources. So one of which is statistics is the study of how to collect, organize, analyze, and interpret numerical information from data. It is both the science of uncertainty and the technology of extracting information from data. It is as well defined as the branch of mathematics that is not only studied theoretically by advanced mathematicians, but one that is used by researchers in many fields to organize, analyze, and summarize data. So one example I can give you that applies statistics is the daily update of Okta research team about the current situation of COVID-19 in the Philippines. So Okta research team gets their information. Okay, so they collect the information from different hospitals, testing centers, quarantine facilities. And once they collect these data from different sources, what they do is that they organize this data. After they have organized this data, they would analyze it. In analyzing this data, they make use of statistical concepts and or mathematical concepts to simplify this complex data. Once they have finished the analysis of the data, then came a result. And then this result will be interpreted and distributed to different media outlets. Okay, so that is what we are now hearing in the news. The current status of COVID-19 infection in the Philippines, like the number of active cases, the number of people who got infected for, let's say, for today, and then the number of people who died because of this, the number of people who recovered from this virus. So those are the things that the Okta research team do. Together with the Okta research team, we also have the DOH who publish their report through the different media outlets. Okay, so that also involves the collection, organization, and analysis of data and drawing of inferences from the samples to the whole population. Okay. This time we are going to determine what makes us different from each other. Okay, so the term that is used for that is a variable. So a variable is a characteristic that varies from one individual member of population to another individual. This variable is divided into two categories. The first is the quantitative variable, and the last is the qualitative variable. For quantitative variable, as you can see here, variables such as height and weight are measured by some type of scale, meaning we make use of an instrument to do the measurement. So through this, you would see two quantities. The first is the numerical value, and followed by the unit of measure. Okay, so in the example on this figure number 2, you would see here examples of quantitative variables such as weight and height. For measuring the weight, we make use of a weighing scale, and the output of that would be the numerical value. In this example, it's 61, and the unit of measure is kilograms. And then upon using a measuring or a tape measure in measuring our height, we would obtain this value. You have the numerical value of 1.68 and the corresponding unit of measure, and that's meters. Okay, so in measuring weight, there are other units that is used to describe it. It can be pounds, it can be metric tons, it could be grams, depending on the object you are measuring. And for the height, we also have centimeters, inches, feet. It can be kilometers, it could be miles, because height is a vertical length, so it is still a unit of length. Okay, so those are examples of quantitative variable. Again, for quantitative variable, we make use of instruments, okay, as some type of scale to determine the value. Whereas for a qualitative variable, in the example that we have here, like the hair color, which is brown, you would obviously not see any numerical value and any unit of measure. But instead, what we see here is just a description. It is a label or an attribute that is non-numerical in nature. Okay? So more on qualitative variables. So again, qualitative variables are measurements which consist of attributes, labels, or other non-numerical characteristics. These are variables that cannot be ordered in a logical or natural way. So as you can see here on the figure, it makes use of our senses. So the sense of hearing, touch, sight, smell, and taste. So examples of these qualitative variables are the color of the eye. It could be brown, black, blue, green, violet, right? So those are examples of the colors of the eye. And some other students would reply yellow. Okay, those with hepatitis have yellow as the color of their eye. And then the name of political party. So let's say, for example, in the US, the name of political party, there are only two, the Republican and the Democrats. And then for the type of transport use, in the Philippines, we have the following: buses, MRT, LRTs, jeepney, motorbike, and even now, the bicycle, right? So those are our modes of transportation. So if you're going to analyze the answers given, so they are just labels. They are just attributes. It does not contain any numerical value. Okay. For quantitative variable, these are numerical measurements that arise from a natural numerical scale that are already innate in a given measuring device. As you can see here, the instruments we have here for measuring the temperature, which is the thermometer, tape measure for height, weighing scale for our weight. We have the sphygmomanometer for blood pressure, and a flask for determining the volume of liquid, all of which has this numerical scale. Okay, so you would see here lines, and then there is a corresponding value that is opposite to that particular line. Okay, so whenever where the pointer points, so that is the corresponding value it is referring to. So the values with these variables can be ordered in a logical or natural way. So meaning we can arrange these values. Let's say, for example, during your high school days or grade school days, your advisor might ask you to stand in line and then arrange yourselves according to height before the flag ceremony begins, right? So you can be arranged. Okay, so let's say for example, arrange yourself according to your weight. Okay, so from the thinnest, the one with the lowest amount of mass in a given body, to the fattest individual. Okay, so this can be arranged, or arrange yourselves according to shoe sizes. Okay, from shortest to the longest. Okay, so examples of which are we have here: sizes of shoes, price of houses, number of semesters studied, and weight of a person. So you might be wondering how we measure the price of house, right? We don't have an instrument like this to measure the price of house, or even the number of semesters. We may not have that, but this would answer the question, because under quantitative variable, we have two types: the discrete and the continuous data. When we say discrete data, these are data or observations that can be counted. Okay, so let's say, for example, how many or how much money, how much is the price of that house? Let's say it's 2 million. So you can count 2 million, right? So there's no need for a weighing scale to measure 2 million. So that is not appropriate for that. How many cats do you have in the house? So you count it. You don't put it on a weighing scale or use a tape measure to count the number of cats, right? So we do counting. How many pieces of paper do you have? You do not put it on a flask to determine the pieces of paper, but we count it, right? Whereas for continuous data that can assume any value, so we need an instrument this time. Let's say, for example, your height. It's 1.78 meters. This time, it contains a decimal figure. Okay, for continuous data. It's not a whole number. We cannot apply counting in here. And let's say, for example, the volume of Coca-Cola you buy in the supermarket. 1.5 liters of Coca-Cola, please. So there is a measurement involved, and also it contains a decimal place value. Okay, so we don't have a decimal place value whenever we are counting. Let's say, for example, your teacher asks you how many students are there in the classroom. You don't say, sir, there is 37.5. How does a 0.5 looks like? Okay, so it is always reported in a whole number. So that's it. So that's why when we are young, our count starts from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we don't have 1.5, 1.7, no. 1, 2, 3, 4, 5, 6, 7. If there is 1.5, 1.75, 1.95, then that would fall under continuous data. Next, we have two branches of statistics, and these branches are descriptive and inferential. So for these branches of statistics, we would be studying about the measures of central tendency, like mean, median, and mode. We also have examples of the measures of spread, which is the variance and standard deviation. For the first measure of central tendency, we have the mean. The mean is the sum of all the values in a given set, divided by the number of values. So you have here at the bottom the formula for computing the mean. By the way, mean is also referred to as your average. Okay, so what we do is we add all the elements in a given set divided by the total number of items. By the way, population mean is represented by this symbol mu. Okay, mu is for population mean. Okay, so how do we determine the mean given this figure on the right? So our elements would be A1, A2, A3, A4, A5. And the total number of items in that set is 5. You would notice a sub 5 divided by 5. So whatever is the subscript here in your a sub n, that would be your divisor. Let's say, for example, there are up to a7. So our divisor would be 7 because there are 7 items in a given set. If that is a12, then divided by 12 because there are 12 items in a given set. Okay, so for this example, the values for A1 is 155, for A2, 155, for A3, 158, for A4, 164, and for A5, it's 168. So what we do, we add all these values divided by how many items? 1, 2, 3, 4, 5. So these values, when added divided by 5, would give us a value equal to 160. Okay? So that is our mean, and that's how we do it. And then for the second measure, it's median. So median is the middle number of a set of numbers arranged in numerical order. Okay. So the first thing that we are going to do is to arrange our data either in increasing or decreasing manner. Okay, because in the definition, it says here, arrange in numerical order. Okay, so for this example on the right, it is arranged from the smallest value to the highest value. So it is in an increasing order. Okay, so regardless whether you arrange it from the highest to lowest or lowest to highest, it doesn't matter. It will not affect the answer that you will come up with. So for this case, there are 5 items in a given set. Okay, so 5 is considered to be an odd number. So if that is an odd number, it is easy to locate the middle number or the middle position. Okay, just like your fingers in the hand. So you know where the middle finger is, right? So there, if you would notice as well, that the number of objects on your left and on your right has the same count. 2 on your left, 2 on your right, and then the one here in red is obviously the middle position. Okay, so since we were able to locate the middle position, then the value that corresponds to that middle position would be your median, which is in this case equal to 158. So what if now the number of item is an even number? Like 2, 2, 4, 6, 8, 10, 12, 14, and so on and so forth. How will you determine the median? It is already stated here. If the number of values in a set is even, then the median is the sum of the 2 middle values divided by 2. So imagine here that we place another object with a measurement of 170, for example, 170. So the 2 middle values would be the one in red and the one in green. So what we do here is we add 158 and 164 and then divide it by 2. Or in other words, we average 158 and 164, and the value that we obtain would be our median. Again, you would notice that the number of objects to your left and then to your right, including the invisible one that we have here, is both equal to 2. Okay? Again, for the median, the first thing you would do is to arrange it, whether in an increasing or decreasing manner. Second is to determine if the number of item is an odd or even. For an odd, you just locate the middle position. And then for even, you locate the middle position, take the average of the 2 middle values. And that is your median. And lastly, we have the mode. Okay, so mode is the most frequently occurring value in a given set. A set can have more than one mode. So the words that you find here at the bottom are just descriptors that is used to describe the mode. If there is only one mode, then it's unimodal. If there are two, we call it bimodal. If that is three or more, we call it a multimodal. Okay? So let us check this example here. So if we are going to check this example, we have here 155 and 155, which occurred twice. 158 only occurred once. As you can see, there is no other 158 in the measurement aside from this one. The same way goes with 164. There are no other 164 in the given measurement. And 168 as well. There are no other 168 here, just this one. So since 155 occurred twice, okay, two times, and the others occurred only once, then therefore we can say that 155 is the most frequently occurring value in the given set. So you can see here that our mode is equal to 155. And to describe that mode that is equal to 155, that is a unimodal. Okay? Second case, what if we add another object here and it contains 168, another measurement equal to 168. This time, 168 occurred twice, the same with 155. That has occurred twice as well. So what would be the mode? The mode would be 155 and 168. Why 155 and 168? Because they are the most frequently occurring value in the set. They both occurred twice. Again, the mode is equal to 155 and 168. And the descriptor for that is a bimodal. And lastly, what if we add two objects here? Two objects. The first one has a measurement of 168 and the second one is 164. Okay, so this time 155 occurred twice, 168 occurred twice, and 164 as well occurred twice. So what would be its mode? The mode would be 155, 168, and 164. All of these measurements occurred twice, and they are the most frequently occurring value in the given set. Well, the descriptor would be it's a multimodal because we have three modes. Again, they are 155, 164, and 168. Again, you look for the value that occurred most frequently. Okay, so in case that there are more than one value and they have the same occurrence, the same value, like the one that we have, 155, 155, 168, 168, 164, 164, all of them occurred twice, and that is the highest, then we report that answer. Okay, so since there is a tie, they have equal values of occurrence and they are the most frequently occurring value, then you report all of those. Next, we have here the measure of dispersion, variance. So variance is defined as the measure of how spread out the distribution is. It gives an indication of how close an individual observation clusters about the mean. So the formula that we have here is actually the formula for population variance for ungrouped data. Okay, so the symbol that is used for this is sigma squared. Okay, sigma squared. So sigma squared, as you can see here, has this representation. So it is for population variance. We have here your x sub I as your ith element from the population, and your x is for the population mean, divided by n, capital N, for your population. So if we are going to read this, this is sigma squared is equal to the summation of the square of the difference between x sub I and x divided by n. Again, the thing that you have to remember here is the symbol that is used for describing population variance. Again, that is sigma squared and capital N for the population. Because for sample variance, it has a different representation. For sample variance, we have S squared to represent it. And instead of capital N, we have here small letter n that correspond to the number of elements in the given sample. Again, if that is capital N, that's for population. If that is small letter n, that is for the sample. If that is S squared, that is for the sample variance. If that is a sigma squared, then that is for population variance. And the second measure is the standard deviation. So standard deviation is defined as the square root of the variance. So if you extract the square root of sigma squared, its square root is just sigma, as you can see here. Okay, so we no longer have the square or the exponent 2 here. But instead, we are now introduced to the square root sign. As mentioned in the definition, your standard deviation is the square root of your variance. Okay? So this is the symbol for standard deviation for population. And the symbol for standard deviation for sample is S. So you extract the square root of S squared, and that is simply S. Okay? And now we proceed to the second branch of statistics, which is the inferential statistics. So inferential statistics is the branch of statistics that involves drawing conclusions about a population based on the information contained in a sample taken from that population. Okay? And it forms a basis for a conclusion regarding a pre-specified objective addressing the underlying population. So let me give you an example that could describe this statement. Drawing conclusions about a population based on the information contained in a sample taken from the population. Okay, so let me make it clear. I'm just going to give an example that is related to this statement and not an example of inferential statistics. Okay, so I just have to make this clear to everyone. Okay, so whenever you will apply for a work and then you got accepted, one of the requirements that your employer will be asking you is to provide a medical certificate that you are fit to work, right? So what you would do is that you go to a clinic or to a hospital and then have yourself checked. So there are physical exams that will be conducted, and then they would also be requiring for blood extraction, right? So there. So we all know, or it is already a fact that based from literature that the volume of blood in one's body is equal to 3,000 ml. Okay, so during blood extraction, we are not drained of our blood. They will not be getting all your blood in the body, but instead they will just get a couple of milliliters of our blood, right? So that couple of milliliters of blood that is taken from your body is this statement. Blood sample taken from your body. Sample taken from your body. And then once they have this sample taken from your body, what they will do is they will analyze it. Okay, so they will perform some procedures to determine the status of your blood or other components in your body. And then after that, they will come up with a result. Okay. So then you have the result already on your hand. What you will do is that you will show it to your doctor. Doc, this is already the result of the medical exam I have. So what the doctor will do? The doctor will now draw conclusions. The doctor will evaluate the measurements or the result that you have. Okay? So if the measurements are within the normal range, then the doctor will give you a result fit to work, right? So that's a good thing to hear. But if the doctor tells you that you need other laboratory exams to verify or to make sure about the result on hand, then you will undergo other medical procedure. Okay, so there. Drawing conclusions about your body, if you are healthy or not, if you are fit to work or not, that is based on the information contained in your blood sample that was taken from your body. Okay? So again, that involves statistics. They collect your blood, they organize it, they analyze it, they interpret, and then the result and summary follows. Okay, so here, the word sample and population has been mentioned numerous times during our discussion. So let us summarize it. Population's definition refers to the collection of all elements possessing common characteristics that comprises the universe. Whereas for sample, it is a subgroup of members of population chosen for participation in the study. Okay, so one important word that we have to include always is the word all when we are describing population. All includes each and every unit of the group. And then for the subgroup, these are only a handful of units of population. That's why we Filipinos came up with this expression, sana all. Okay? Sana all. So because we all wanted to be part of that, just like the ayuda from the government. So everybody or all is expecting to receive ayuda from the government. But in reality, there are only a handful of units who receive ayuda from the government. Okay? So there. So for example, let's say for example, the IT students from first year to fourth year is 200. What we will do during election of officers is we nominate some of the qualified students, and those who are elected are only the handful of IT students, not all. Okay, just a handful, a few number of students who were chosen to be the officers of the organization. Okay. So in describing population, we make use of the word parameter. And then for sample, we call it is statistics. So how do we do the data collection for population? So for population, we conduct complete enumeration or census. So census, the word census. So the government agency responsible for this is the Philippine Statistics Authority, okay, or the NSO before, the National Statistics Office. So in conducting census, we include everyone in the barangay, everyone in the municipality, and no one is left behind. So these are people who knocks on your door and ask details about the household. Sometimes they would be asking you how many people are there in your house, how many families are living, so how many children, how many adults, what are their ages, their gender, their job, if they are working, or if they are students. Okay, so those are the things that they usually ask. And for the sample, we make use of sample survey or sampling. Okay, so for sampling, we have different methods still. Okay, so that is another topic to be discussed. And then what is the common way of data collection for sample? We make use of sample survey. In a sample survey, it contains the demographics of your participants or your respondents. These demographics, the name, age, gender, the year level, will be of use when reporting this in their perhaps project study, their thesis, or their capstone. Okay. So aside from the demographics that they have, they also have questions that you need to answer. So there are options there that you will choose that correspond to your choice of answer. And lastly, the population is focused on identifying the characteristics of everyone, while for example, it's just making inferences about the population. So let us determine now the purpose of statistics. Is there a purpose for studying statistics? So what benefit would we get from it? So the first one is to present facts in definite form, meaning our ideas would not be vague and indefinite. When we say vague, it means unclear. Okay, so not clear. Indefinite, there's no assurance to that. We're not definite about it. There's no way of measuring it. There's no way of proving it because there are no basis for that. Just like when we say indefinite leave, so you don't know when you will be coming back. Okay, so as an example, we have here population is increasing at a faster rate. So why is it under indefinite? Because we don't know how fast is fast. How much has increased? Okay, because we don't have a reference to that. We don't have any value. As compared for definite, we have numbers that are used to describe what we want to convey. So population in 2004 would be 15% more as compared to 1990. So we are going to forecast the population in 2004 given the growth rate of 15% and the population during the 1990s. So let's say, for example, the population during the 1990s is 1 million. We get 15% of that and we add it to 1 million and we will be able to predict or forecast the population in 2004. Okay, note that I made use of the word forecast because later on I will use that again in one of the purposes of statistics. So if our idea is clear and definite, it adds precision to the facts. So statistics helps in simplifying complex data to simple. What's the purpose of that? Why do we simplify? To make them understandable by many, if not by all, just many of them. The data may be presented in a form of graph, diagram, or through an average or coefficients. So this is how we can simplify complex data. It is through the uses of graph and diagram. So examples of graph, like pie graph, bar graph, line graph. So those are examples of graphs. Right? Third is comparison. So if we have values, we have data, we can compare it, right? So just like what we have in number 1, we can compare the population in 1990 and 2004. Let's say, for example, in 1990, the population is 1 million. And then after how many years, the population in 2004 is already 2 million. So how will you compare it? The population has doubled from 1990, 1 million to 2004, which is 2 million. Comparisons. Fourth is formulating and testing of hypotheses. This is widely used in inferential statistics. So what do we do? First is we have to understand what is the meaning of hypothesis. Hypothesis is defined as an educated guess. Why educated guess? Because we are guessing based from evidences. We are guessing based on data. We are not guessing out of nowhere. Okay? So there is a basis for us saying those things. So statistical methods help us formulate and test the hypothesis or a new theory. So we test our guess whether that is there is a probability of happening. So we have to accept it, or there is a probability of not happening. So we have to reject it. Okay. So in our discussion in inferential statistics, we would be dealing with the formulation and testing of hypotheses. Number 5 would be forecasting. As I mentioned in number 1, take note of the word I use, that is forecasting. So forecasting is used to prediction only, okay? The future course of action of the phenomena. Just like in the news, we call it weather forecasting, right? We're just predicting because the action of nature is unpredictable. It can change anytime during the day. Just like, for example, now, the outside is sunny. In the afternoon, it would be cloudy, and in the evening, it will rain. It's very unpredictable, right? Policy making. So how much food is required to be imported in 2007 or 2021, let's say, for example. And 7, it enlarges knowledge. So statistics enables one to enlarge his horizon. It also widens his thinking and reasoning power. So just like what Ernie Baron used to say, knowledge is power. The more we know, the more powerful our reasoning becomes. It also helps us to reach to a rational conclusion. So when we say rational conclusion, we base our conclusion on data and facts, not on our emotions or opinion. Okay. And to measure uncertainty. The more we are clear about things, the the lesser we become uncertain. Just like the vaccine that we have right now. We have a lot of data about Moderna, AstraZeneca, what else? Johnson and Johnson, and then the other one, Pfizer. Right? We know a lot of information about them. That's why people opt to use them. More people. That is their choice of vaccine. Unlike Sinovac, who has that has limited literature, or we have limited knowledge about, because they release not so much information about it. That's why people are very uncertain of it. Some of the people I have met who have been given Sinovac because they accepted that because they have no choice. That is the available um, vaccine for them. But just like what the DOH says, it is important. It is better that you have a vaccine compared to none. Okay, so based from the data that we have, most of the people now that are confined in the hospitals and under serious problem are those without vaccines. And those with vaccines are recovering very well, and they are sent out a few days after they are confined. Okay. So what is the importance of statistics in business? So it says here that it helps a businessman to plan his production according to the taste and preference of the customer. So that is where you base your production on what the in economics, it has something to do also with the law of supply and demand. So what does the law of supply and demand tells us? If the supply is less and the demand is high, so the price is high. If there are a lot of supply and there is less demand, so the price is very low. And for mathematics, statistics and mathematics are interrelated with each other. So as you can see, from the previous slides, let's say, for example, in the computation of population variance, we made use of the concepts of division, subtraction, exponents, summation. So those are mathematical concepts used by statistics. Okay. And then for banking, the bankers use statistical approaches to estimate the number of depositors and their claims for a certain day. Okay, so officers from the bank should know how much money that goes into their bank and then how much money goes out of their bank through withdrawal so that they can plan how much money they should have in a given day. Okay, so that ends our virtual class for this week. Okay,